Van der Waal equation of state for real gases. In ideal gas, we have the gas equation PV equal to nRT, but in real gas, you have a pressure correction term small p and you have a volume correction term B. So the Van der Waal equation is P plus A by V square into V minus B equal to nRT. Here the pressure correction term P equal to A divided by V square, where A is a constant and V is the volume. So why pressure correction term P comes in Van der Waal equation or for real gases? Because in real gases the pressure correction term arises due to the intermolecular attractive force. You have intermolecular force between the gaseous molecules, and also you have the intermolecular force between the gaseous molecule and the molecule present in the wall of the container. The intermolecular attractive force, this depends upon the number of molecules striking unit area on the wall of the container, and it also depends upon the number of molecules present in the container, and both these factors depend upon the density of the gas. That is why the pressure correction term small p is proportional to square of the density, and we know density is given by the formula mass per unit volume. That is why the pressure correction term P is proportional to 1 by volume square. So the pressure correction term P small p, that will be equal to a constant A divided by V square, where V is the volume of the gas. And what is the reason for the volume correction term? The volume correction term B arises due to the volume of the gas molecules. In the ideal gas, we have neglected the volume of the gas molecules, but in real gas, we have to find out the volume correction term, or we have to take the difference between the volume of the container and the volume which arises due to the gas molecules. So let us find out what will be the magnitude of this volume correction term, that is small b. Suppose you have n number of gas molecules in the container and a radius of one each gas molecule is equal to, suppose, say r. So what will be the volume of the gas molecule? Volume of the gas molecule X will be equal to 4 by 3 pi r cube. So this is the one gas molecule. Suppose you have two molecules, this is one molecule and this is one molecule, then what will be the distance between the radii? The distance between the radii will be equal to 2r. So if you draw a sphere of radius 2r, then this radius is called sphere of influence, and within this sphere no other molecule can come. So what will be the volume of this sphere of influence? Volume of sphere of influence will be equal to 4 by 3 pi into 2r cube, that is equal to 4 by 3 pi into 8r cube. So this will be equal to 8 times the volume of individual gas molecule. Suppose we enter gas molecule one by one. So what will be the space available for the first molecule? This will be equal to V, and the volume available for the second molecule is equal to V minus S. Volume available for the third molecule will be equal to V minus 2S. So the volume available for the nth molecule will be equal to V minus n minus 1 into S. So what will be the average space available for the molecule? That is equal to the arithmetic mean of the volume occupied by each molecule, that is equal to V plus V minus S plus V minus 2S up to V minus n plus n minus 1 into S divided by n. So you have a plus sign, and we have to find out the arithmetic mean of this quantity. And here you have n into V, So n into V divided by n, that is equal to V minus, if you take S common, S by n common, then you have in the bracket 1 plus 2 plus 3 up to n minus 1. And if you take the sum of this term using the formula Sn, that is sum of n numbers, the formula is n by 2, 2a plus n minus 1 into d. A is the first term and d is the difference. So n minus 1 divided by 2, because the last term is n minus 1. So n minus 1 divided by 2, then 2 into a, the difference is, first term is 1. So 2 into 1, that is 2, plus n minus 1, that is equal to n minus 1 minus 1. So it is equal to n minus 2. So 2 cancels. So you have n into n minus 1 divided by 2. So the sum of this term is equal to n minus 1 into n divided by 2. So if you simplify it, first term is V minus n into S divided by 2, and the second term will be equal to S divided by 2. Because here you cancel n, so n multiplied by S divided by 2 plus S by 2. So you neglect S by 2 in comparison to this factor, because this is a very big number. In comparison to this number, you can neglect x by 2. So the final value will be equal to V minus n into, what will be the value of S? We have find out the value of S equal to, that means the volume of the sphere of influence, that is equal to 8 times the volume of each molecule. So 8 into 8x, n into 8x divided by 2. So this will be equal to 4 times nx. This factor will be equal to 4 times nx. So the volume correction term, this is the volume correction term B. That means the volume of the gas molecules is equal to n number, n times, 4n times the volume of individual molecule. So you cannot neglect this volume. That is why Van der Waal added a volume correction term, that is B. So the Van der Waal equation now becomes P plus A by V square. This is from the pressure correction term, into V minus B equal to nRT. So in the examination you will have question like derive Van der Waal equation of state for real gases, and in the next video we will discuss about the values of critical constants. Thank you.